Hello and welcome to Math 253 Calculus 3 here at Cañada College. My name is Lapuz, and in this video we will take a look at checkpoint 6.56. In this problem we have a metal and shape modeled by a paraboloid given by z is equal to x squared plus y squared. So this is a circular paraboloid pointing upwards with a vertex at 0, and we're letting z go from 0 to 4. The density of the metal is given by this row. It's just a function of z. There's no x and y in it, so that's fine. And they want us to find the mass. All right, so mass is going to be density times the area, and the area is going to be the surface area that we will be looking for. So we begin by working with this paraboloid. This is your paraboloid, and it goes up to 4, so we will probably need this shadow later on the xy plane. So this is x squared plus y squared. When z is equal to 4, that's the top part right here, and so this will have a radius of 2. Okay. Now let's parameterize that, and we'll use the simple, what we've been calling as the graph parameterization, R of, we can call it U and V. It's kind of better to call it X and Y because the X is just going to be whatever that first parameter is, and the Y is going to be whatever the second parameter is. But we'll just keep it at that. Here we have U squared plus V squared, your Z value, which is X squared plus Y squared. All right, we'll run through our procedure, finding the derivative of the parameterization with respect to U, and then finding the derivative of the parameterization with respect to V. And so our derivative with respect to U is 1, 0, 2U. Derivative with respect to V is 1, 0, 1, 2V. And so we'll eventually need the cross product. Well, the magnitude also, but let's hold on until we find the cross product. So we will get negative 2U, negative 2V, and positive 1 for the cross product. All right. So now that we have a cross product, we'll take its magnitude, RU cross RV, and this is going to be the square root of 2U squared and 2V squared, all those quantities squared, plus 1. So just to get this kind of straightened out, there's a 2, or call it a 4, under square root. U squared plus V squared, which they have, plus 1. And we'll keep an eye on this thing and looking at, we didn't talk about the domain for this, but the domain for this parameterization is going to be the circle, and so that's probably going to put us into polar coordinates, which we will deal with later, and it's all especially useful because we have a U squared and V squared. Okay, now let's work on the mass. The mass here is rho. We have rho, and we want to put this parameterization in there, R of UV. And it looks like there's only a Z component, so this is X squared plus, well, I'll call it U squared, plus V squared. That's the Z, and then plus 1. So that's it for that. And now we'll put it together into our integral. Our surface, or our mass, is going to be the double integral of the surface area of rho dot. This is not a dot, this is just a times ds. Okay, and we know that in our surface integral, we will turn this into a double integral of this thing. So that's U squared plus V squared plus 1 times the magnitude of the cross product. That's a square root of 4u squared plus v squared plus 1 dA. So we'll call it dA and then call this d temporarily, but like I said, we probably want to go to polar coordinates here. And so in polar coordinates, we take a look at our r limits going from 0 to 2, and our theta goes all the way around from 0 to 2 pi. So we'll set up our double integral. This is going to be r squared plus 1. This is going to be 4r squared plus 1 under a square root, and our dA holds the extra r, and if we integrate with respect to r first, our limits are going to go from 0 to 2, and then theta, our limits are going to go from 0 to 2 pi. Okay, this I imagine might be doable by hand, but there's a couple of r squareds. This one has an r squared plus 1, this one has a 4r squared plus 1, so I would rather punch this into our Wolfram, and let's see, inside here we're going to get r squared plus 1, and we will multiply this with the square root of 4r squared and then a plus 1, and then we have an extra r out there, integrating with respect to r from 0 to 2, and then integrating with respect to theta from 0 to 2 pi. All right, and hopefully things will run smoothly. And here we have about 120.6. All right. So I think that's good. And we got a result. So that's it. We're done. I hope that helps. Good luck.